Okay, welcome to this video on solving problems with quadratics, or problem solving. The most difficult part about this is constructing the equation. So with this video, I'm just going to go through with you how we construct the equation that's going to describe the problem that we solve. And if you want to know how to solve the problem, you can look at the answers. So in the first one here, we have two integers differ by 12. And the sum of their squares is 74. So whenever we're talking about unknowns, we always like to use the value x. So if we have one of the integers being x and the other integer being x take 12, the sum of their squares is 74. So this means x squared plus x take 12 squared equals 74. We just need to expand, collect like terms, and move everything over to one side so we can factorise. The sum of a number and its reciprocal is 26 on 5. So if you remember, if we have the number 2, then its reciprocal is going to be 1 on 2. We basically flip it on its head. So we have an unknown number, again x, and x plus 1 on top of x is going to be equal to 26 on 5. Okay, now this isn't a quadratic, but we can easily make it one. If you remember, the most basic rule of algebra is whatever we do to one side, we have to do to the other, but we can do absolutely anything we want. So we're going to multiply both sides by x. Okay, so that's going to make this x squared plus 1 equals 26 on 5 times x. And now this is a quadratic. We can move this term over, make it equal to 0. Feel free to multiply by 5 if you don't like that denominator, but that's how we solve that one using that equation there. Okay, number 3. The product of two consecutive even numbers is 360. So a consecutive even number would be, for example, 2 and then 4. 4 comes after 2. It is the next even number. 4 and 6. 6 and 8. So we're finding two consecutive even numbers. So again, they're unknown, but they're going to be x and x plus 2. Okay, and it says the product of these two is 360. So we have x times x plus 2 equals 360. Expand, move over to one side, you've got a quadratic. Number 4, the number of diagonals of an n-sided polygon is given by the formula d equals blah blah. So we can see all we have to do here is put 90, because 90 is the number of diagonals where d is. Okay, so we're going to have 90 equals half n times n take 3. Okay, again, expand, move stuff over to one side, and you'll be able to see that one. Alright, 5, 6 and 7 are good questions because they start getting into stuff about shapes. Okay, so in number 5, the length of a rectangle is 4 centimeters longer than its width. Okay, so if we call its width x, then what's its length going to be? It's 4 centimeters longer, so it's going to be x plus 4. Alright, and obviously this isn't drawn to scale, but that's fine. And then it says the rectangle has an area of 26 centimeters squared. What does this mean? It means x times by x plus 4 is equal to 26. Okay, again, expand, collect your like terms, move it over to one side, and you have a quadratic. Okay, question 6. We have a 3D problem. Rectangular box has a square base. Its height is 1 centimeter longer than its base. All right, and we're told the surface area. So if the base is x, all right, and it's a square, that means that length is going to be x. The bottom is x squared. The top is the same, so the top is going to be x squared. So the bottom and the top is going to be 2x squared, and we're told the height of it is x plus 1. Okay, which means the area of all of these sides is just going to be x times by x plus 1. And how many is there? There's 4 of them. 4 times x plus 1. That's going to give us the total surface area of this shape. Okay, we expand, collect like terms, and we're told the surface area is equal to 240. So now we can solve that quadratic. Okay, number 7. An open box can hold 80 centimeters cubed. Okay, so it's open, it doesn't have a lid. It's made from a square piece of tin plate, and it's got these 3 centimeters cut out the side. So we want to know the original dimensions. If we go ahead and call this length, as in the original length of the tin, x, then this length here is going to be x take 6, okay, which is this length here and this length here. So the bottom of this box is going to be x take 6 squared, yeah, x take 6 times by x take 6, and it is 3 centimeters high, okay, which means the volume is going to be 3 times the base, and the volume is equal to 80, again one that we can expand, collect like terms, and solve for x. Number 8, is it possible to bend a 20 centimeter length of wire into a rectangle with area 30 centimeters? Okay, so we've got a length of wire that's 20 centimeters, and we want to make this into a rectangle. So obviously we're going to bend it in half, okay, and then somehow have lengths throughout it that are going to make it equal to an area of 30 centimeters. We want to see if that is possible. So we're going to draw a rectangle, and what we've got is, if we call this length x, then this length here is going to be 10 take away x. Alright, this length here would be x, this length would be 10 take away x. If we add up all of the lengths, so the total perimeter of this shape, 10 take x plus 10 take x, it's going to be 20 take away 2x plus x, it's going to be 20. So it has a perimeter of 20 centimeters. The area is 10 take x times by x. Can this ever equal 30? Okay, so we have to expand, collect like terms, and have a crack at solving that. Okay, 9's not a very good question. We might go through that in class. 10 and 11 require you to construct a quadratic equation. So I'll leave you guys to have a go at constructing those equations and see how you go with those two. Hopefully this video has helped you construct some of these equations.